Good morning, guys. Sorry I couldn't be there today, so I thought I'd make a video just so we don't fall behind. So let's go ahead and we're going to just start with the warm-up. It says, here are two puzzles that involve side lengths and areas of rectangles. Can you find the missing area? So using kind of like deductive reasoning, you might have to work backwards. But your goal here in the first one is to find the area of this rectangle. And then in the second one, you are finding the missing side length. So I would suggest pausing the video here and trying it on your own. Okay, so hopefully you guys attempted this on your own. I'm gonna walk you through how I would personally solve this. So the first thing I'm looking at is I know that this is 8 because the side across from it is also 8. So now I'm kind of tasked with trying to figure out like, well, what's this amount right there, that little bit? Well, if I know from here to here it is 5 inches and from here to here it is 3, then the remaining piece here is going to be 2. All right, let me zoom in on this. So now I know that the length is 10. Then I want to find the width of the rectangle. So what I know, obviously, is that whole thing right there is 10. And from, let's say, like from here to here is 8, right? So to go the extra bit to make it 10 would just be an extra 2, right? So my area, which is always length, I'll write this out, times width, in this case is going to be 10 times 2, and I get an answer of then 20 inches squared. Now for this one's unique, right? Now we're working backwards. Now that we know that area is length times width, we want to figure out like, well, how did I get certain areas, right? So for instance, like I happen to just start right here, right? If my area is length times width, I happen to have an area of 60 and a length of 12. So what could the width be, right? I would divide both sides by 12 and the width would be 5. So I now know that this is 5. Oops, sorry, I don't know why I put W. This is 5. Okay, so now I know that from here to here, right, is a total of 8. So now using this area, okay, so 48 was, we got that by doing 8 times an unknown width. So again, if I were to divide both sides by 8, then I get a width of 6. So I know that this is 6. And then this is 6. Now if I know the whole thing is 11 from here to here, that makes this 5 if I needed it. So now my goal is to figure out, right, the inches of that length of that top rectangle. So what I would probably do is use the fact that I know that the opposite length is 12, right? So why is that helpful? Well, from here to here is 12. I know 8. I know 3 and 5 gives me a total of 8. If I deduct that from 12, that gives me 4. So now, if I know my area is 36, my width is 4, I'm trying to figure out the length. I would divide both sides by 4, and I get a length of 9. Okay, so for today's notes, our goal today is to start to factor. So being able to go forwards and backwards between standard and factored form. So in example 1, it says, use a diagram to show that each pair of expressions is equivalent. So we can either do the box diagram or we can do distributive method. So I'm a fan of doing just distributive method. So I'm going to take x and I'm going to multiply it to x and 3. And so I get x squared plus 3x. Oh, look at that. It's the same as that. Then for b, you know what's kind of interesting? I don't personally like how they wrote that. We don't ever write plus and negative. So I'm actually going to rewrite that as x minus 6. And then we're going to distribute. And I get x times x is x squared. And then x times 6 is 6x. Looking at C, this is where we have to distribute twice. So I distribute my x to get x squared plus 4x. And then just to show you how I'm going to distribute again, I'll use a different color here. So now I'm going to distribute the 2 and I get 2x plus 8. Now I'm going to combine like terms, and I get x squared plus 6x plus 8. So this is a very much a review, so I would highly suggest you guys pause the video here to try a lot of these on your own. I would say though for E, I would personally rewrite that, right? We don't write plus and negative in algebra now, so I would rewrite that as subtraction and then go ahead and try that on your own. So going back to D, if I were to distribute, I'm going to get x squared plus 10x. Distribute the 4, and I get 4x plus 40, and that combines to give me 14x there, and everything else comes down. So hopefully, what I want you to pay attention to is like what, do you see a pattern when we're multiplying and simplifying? Okay, because that pattern is going to help us to factor. So going to E, let's distribute. So I get x squared minus x, distribute the 5, get minus 5x, now plus 5, because those two negatives. I get x squared minus 6x plus 5. So again, do you see any correlation between these numbers and these numbers? Last but not least, we will distribute. We get x squared minus 7x, distribute the negative 1, get another negative x, but now plus 7. And we combine to get negative 8x, and everything else comes down. So using this pattern, like I said, it's going to help us to go forwards and backwards from factor to standard form. So we know in that first one, we're going to get x squared plus 7x, right? Because I'm just distributing an x. Well, you want to ask yourself, well, what did I multiply to get x squared plus 9x? And I would have taken an x and multiplied it to x plus 9, all right? So I'm like dividing out. It's like I'm dividing out an x. And the same thing's going to happen to the next one where I take out an x and I'm left with x times x minus 8. Okay, now the pattern that I was hoping you guys would recognize is that when I multiply those two numbers here, that's going to give me 12. But if I add them, gives me my middle term. And that was the purpose for all of those kind of like puzzle type questions, like what number multiplies to this but adds to that. So now you want to think for this, okay, well, what multiplies, oops, I spelled that wrong, multiplies to 12 and adds to 13. And hopefully you're thinking, well, 12 and 1. And that's what our factored answer would be. So then to get that into standard form really quickly, I'm going to add, and that's going to give me negative 8. Then I will multiply, and I get positive 12. Okay, so again, multiplies to 12, adds to negative 7. And that would be negative 3 and negative 4. And then the next one, I would say, if you ever get stuck, you could always start with your parentheses. You're going to start with x and x. This one's going to be both positive because it needs to multiply to a positive and add to a positive. This would be 3 and 3. So why don't, at this point, go ahead and pause and try these on your own. Stop at that last one because that's a challenge. So for this one, I would have x plus 9 and x plus 1. Again, that multiplies to 9 but adds to 10. Kind of similar in the next one because you're trying to still multiply to 9, but now you want to add to negative 10. So what you'd want to do is have negative values, right? That negative is going to multiply to a positive, but add to a negative. And then similarly for this one, last one I had you do on your own, right? Multiplies to a positive, but adds to negative 6. Excuse me. So for this last one, right, they multiply and add. So what this is going to factor to would be x plus m and x plus n.